So today we are actually going to start the next topic of our machine learning, that is decision tree. Okay. Now until here, what we have done is we have learned few machine learning algorithms. Okay, so let's say when it comes to regression, we know what is linear regression, we know what is polynomial regression, right? We have also done with the part of your, let's say, kn, or you can say k nearest regressor. And yesterday I have given you the assignment for svr, that is support vector regressor, right? So let's have one more, we can say, machine learning algorithm in our toolkit. Okay, this is called as decision tree. Okay, so by now what we have done is, if you remember the working of logistic regression, right? If you remember the working of logistic regression, so what we used to have is, so let's suppose there is a graph, right? And there are two classes, right? There is class red over here at the top, and then we have, let's say, one class blue, let's say green at the bottom. Okay, class red and class green. So that is what we used to have in our logistic regression. And if you can observe this, right, we can understand that very clearly, that this data, this class, these two categories is very much linearly separable. We can separate these two classes by using a single line, right? The data, the classes, is kind of a linearly separable. We can separate that using a single line. Okay, then we have learned an algorithm which is support vector machine, which actually deals with some kind of a kernel function to map the lower dimension data into higher dimension subspace, to deal with this non-linearity or non, let's say, linearly separable data, right? Apart from that, let's suppose we have, let's say, one scenario. Okay, let's suppose we have this scenario where we have the same two classes, class red and class green. Okay, we have same two classes, that is class red and class green, right? So let's say this is red class, but here in this red class there is some impurity. Okay, here in this red class there is some impurity. That is, there are some data point in the class, or you can say in the group red, which is from some different class, right? So there are two impurities over here. I will not say it as error, but these are the impurity, right? This category, right, this particular category has mixture of two classes, so this class is impure, right? Similarly, let's say we have here the class green, but again the green class is also have some amount of impurity in it. Okay, there are some red data points, there are some data point which belongs to class red. All right, there are some data points which belongs to class red. Okay, now we want to create a hyperplane or a classification boundary or decision boundary which can exactly separate the two categories here, right? Which can exactly separate these two categories from here. So what to do? By using your logistic regression, we are not able to do so, because logistic regression will create some kind of this decision boundary. And again, as you can see, there are some misclassification, there are 2 points. Okay, sorry, not this one, there are points from some different class here. So this decision boundary not at all good. Again, there are two different points here which belongs to class red, right? So if I consider this decision boundary, right, there will be some amount of impurity, some misclassification, or some amount of error when we test our model. Okay, there will be majority of error, you will say. So I cannot go with this decision boundary. One thing that we can do is we can have something called as SVM or support vector machine, which can, let's say, plot these data points into higher dimension, and by that, by some other dimension, we'll be able to separate these two classes. But what if I don't want to use SVM? What are other ways to deal with this kind of a data? What are other ways to handle non-linearly separable data? Okay, this is where decision tree comes into the picture. Okay, what decision tree does is it will create not one but multiple decision boundary. Okay, it will create not one but multiple decision boundary so that it can classify the classes, so that it can classify the data points correctly. Now if you see this particular, these two decision boundary, okay, in this particular region there is no data point which belongs to some other category rather than green. If you see this particular region, there is no data point which belongs to some other data point or some other category rather than red. Again, here, if you see this particular region, there are no different category rather than green. So definitely we can trust these two hyperplane, that yes, these two hyperplane, these two decision boundary, these two features will exactly help us to identify that this data point belongs to class red and this point belongs to class green, right? So this is what decision tree does. We are not here creating one but multiple decision boundary based on multiple features. I repeat, we are creating multiple decision boundaries. In your word, we are creating multiple hyperplane in order to fit our data well. Okay, we are selecting multiple features. Okay, in order to create these decision boundary. So that is how decision tree works. Okay, so if we go with this particular definition, that what exactly decision tree is, right? So basically a decision tree is the arrangement of the data in a tree structure where each node, okay, whereas each node data is separated to different branches according to the value or attribute at the node. Now definitely based on this example, based on this graph, it is very much difficult to understand the definition that I've said. So let me use some good examples, right? Some practical real life example in order to explain you this particular definition, that what exactly decision tree is. But let me know, ki, is it clear that why we need a decision tree and what exactly decision tree does? I repeat, decision tree here creates multiple decision boundary, or you can say hyperplane, based on multiple features in order to correctly classify your data without having more impurities in it. Is that clear, guys?